Hey guys, it's Mr. Fourth Dimension. Welcome to another episode of the Geo Project. So I think what we just finished up doing was rotating the segment. In the segment collision problem, we were rotating the segments so that one of them would be vertical, and then we could use the vertical collision detection. So we've got some to-dos and maybe things to speed it up, but we want to test if this is right. And I did think of another to-do, because last time we worked on all this operator stuff, right? And now there might be places throughout our code where we actually want to update what we're doing with vectors. So what we're going to do here is go make sure to use these where appropriate throughout the code. Because we just want to make sure that if we have this facility available, that everything is running through it, because no point in having slightly out-of-date code. If these facilities are available, we should be using them so that our code is sort of standardized. Things like, I think I just saw one, like all this, we're going to change that into the new vector notation. Now that we've built up a little bit more of that. But let's get testing this segment stuff. So the signature here is just two pairs of points, a pair of segments. So I don't think we're doing full casts right now, right? We're just doing geocast, and we'll do a full cast version as well. Remember, the difference between a full cast and a non-full cast is that the full cast gives us information about what type of collision, if it was a tangential collision or complete overlap collision between the two shapes. Segment, right? And then what we want to do is we want to say, look, if there's a hit, do one thing, else do the other thing. The one thing that we're going to do when there is a hit is we're going to report a hit, and then we're going to report the T like we were doing before. Put in a new line, and that is cast.t, I think, right? Yep. And then same idea down here is if we get a miss, we'll do this. And now we need to make a pair of segments. So we have one right there. Let's make another one. Well, actually, we're probably going to simplify all of them. So let's start with something really easy to think about. We'll go from the point 1, 1 to the point 5, 5, and then we'll have another one that goes from the point 1, 5, whoops, getting ahead of myself there, to the point 5, 1. Now if I've thought this through correctly, that should create two crisscrossing lines, and they should have a segment right at point 5. I might have not thought that through correctly, but I think that's right. Because they should just be the diagonal parts of a rectangle, right? Not saying there's a miss. So what's it doing? It might be a bug, of course. 1, 1 to 1, 5 would look like that. And then 1, 5 to 5, 1 would look like that. Okay, there might be a bug. So let's take a look right here at what the rotated points are. So we're going to printf rotated q1 equals, and then we need an f and an f, and then that'll be q1.x, q1.y, and then we want a q2. Still don't have that convenient point printing system. Maybe I'll take some time to research and figure that out for next time, because I've said a few times now we should take time to do that. So it's going from 0, 4 to 4, 0. Yeah, those aren't rotated. I didn't use the rotated versions. And now I see the problem, I think, because I don't think I used the rotated versions down below either, did I? I'm using Q1 and Q2 directly. Those need to be the rotated versions. So I'm gonna keep the print because there might still be a bug there, but I want to see if we switch to that, if that fixes it. Okay, so it's still a bug. The x, y, the y's are the same, and the x's are different. That's not what we want. We want the y's to be different. So it seems like it rotated to the wrong place, and then why this is missing like that is also kind of spectacular. So let's see, cosine, sine, negative sine, cosine, cosine, sine. Yeah, so those look right to me. I'll review again to make sure I'm doing all of that right. But maybe I calculated d theta wrong. So the idea is I want to point this thing upwards. So here's my first question, is what was theta to begin with? It should be, well, it should either be like, hold on, can't think while I'm typing. It should either be like pi, like 3/4 of pi, or maybe 7/4 of pi. Because we have the line that we're looking at is the one going this way, so 3/4 of pi points that way. I think that would be the way it goes, right? X of 1, y of 5. Okay, so no, it'll be 7 pi over 4, I think. Let's give that a run. Well, let me give it a build, and then a run. So it's saying 5.4. Let's see. 3.14. Oh, come on. 3.1415926 times 7 divided by 4. Yeah, so that isn't the problem. Let's see what it calculates for d theta. Jeez, oh Pete's. I'm not so good with my keyboard laptop because I'm always switching between having numlock on and off, and then sometimes I start typing with numlock still on, and I try not to use my home and end key, and it gets weird. Let's run that. What is d theta? Negative 3.92. So why would it be negative? I think we're calculating that wrong, right? Because, well, basically the idea is that we're going to take whatever the current angle is and add this much. It should end up at pi over... Why pi over 2? That would point to the left. It should be pi over 4. Oh, wait. No. It should be pi over 2. Man, I'm really easily confused by that. That should be actually like this now. So half pi points up. And we want it to point up. But it currently points down and to the right. It should be computing a d theta. Well, it's computing this d theta with this being the large positive that geodirection returns. So that's why it's a negative. So I'm guessing if we take that and we subtract from it the 3.926991, and then multiply that by 2, we get something close to pi. Yep. The reason that would be close to pi is if it rotated correctly, it'd be half pi, and then times 2 would be full pi. So I'm not screwing any tiny detail up here. D theta. Take the sine and the cosine of each. Or of d theta, that is. So what are the results for that? Actually, I want to, get numlock off again. Oops, that doesn't help. Cosine of theta, cos d theta, and then we want the sine of theta, sin d theta. Oops, wrong one. So it's coming out as -7 and positive. So those should both be. Why would it be a cosine of negative? It shouldn't. If it's pointing down and to the right, the cosine should be coming out positive, if I'm understanding correctly, and the sine should be coming out negative. Right? So, remind me again what the d theta was. Oh, the d theta is some negative number. So let me think. I gotta visualize where d theta is to understand this. F d theta. So d theta is negative 3.92. So I'm guessing that's that should be, let's see, 1/4 of a circle and then a half a circle. So that's pi and a quarter, or 5/4 pi, right? So I'll numlock back on 1415926 times 5 divided by 4 should give us that, right? So that means we're pointing in that direction negatively. So if you go all the way around the circle, the negative direction, yeah, x would be the x in that direction is negative, and the y in that direction is positive. So the cosine goes with the x, and the sine goes with the y. Those seem reasonable. And the negative point, and the 0.7 would be half of the square root of 2, if I remember correctly. Square root of 2 divided by 2. Yes, so those are completely right. Okay, let's look at my rotation code then. Maybe the problem is here. How do you rotate something that is at the point 1, 0, right? So if it's on the x-axis at a y of 0 and an x of 1, and I want to rotate it, I want to set its new, yeah, so its new x becomes the cosine of whatever the angle is, so that if it's like a cosine that comes out -1, then that means that the angle actually says reverse this all the way around the other side. If it comes out as being 0, that means it's pointing right up and down, and the x part of this is just out, you know, it's just 0. And then it's time plus the q1 dot sine, is that right? Let's see, that would mean we want to point on the y-axis at the point 0, 1. If you rotate that by 1/4 of a circle, then sine becomes positive 1, cosine becomes 0, so then the new x would be the -1, right? If it's pointed up, sine, maybe I want to switch these negatives. Maybe these negatives are oriented the wrong way. So I know that's the shape of the matrix, but maybe that's for rotating with the other kind of screen coordinates. Let me see if that runs any differently. Ah! There we go. That gave us the 0.5 I was expecting. So what had happened there was this negative I was putting down here actually belonged up here. And since I got that wrong and I said that I thought I had it memorized, that means that next time I have to describe this in detail with a diagram, just to cement it in my head and to make sure I have clarified any confusions I've created. So that's what we'll do next time, but it looks like we fixed a bug. I'll describe it with the diagram, and we'll continue testing this function next time. See you guys then.